There are no specific electrical code requirements for medical spaces like physical therapy offices. However, it is always good practice to follow best practices for safety and functionality. Romex, also known as NM cable, is generally acceptable for new wiring in this type of space. However, it is important to follow the manufacturer's instructions for installation and directing for long runs. To run new circuits from the panel to the space above the ceiling, you can use one of the following methods. Firstly, install a new electrical metallic tubing, also known as EMT conduit with pull points, also known as junction boxes, approximately every 10 feet or so. This will allow pulling new wires without dirting. Secondly, install wire mold along the ceiling joist to run new circuits. This method is less intrusive than EMT but provides less protection for the wires. When running NM cable perpendicular to ceiling joists, it is acceptable to staple it to either the top or bottom of the joist. For new drop-in fixtures, it is recommended to use jack chain for support instead of the existing wire grid. This will ensure proper alignment and safety. Regarding receptacle spacing, a minimum spacing of 3 feet between receptacles is generally recommended for the reception countertop. For regular walls, a minimum spacing of 12 feet between receptacles is required by code. For the patient area, there is no specific code requirement, but it is recommended to provide ample receptacles for medical equipment and patient comfort. Ensure all wiring is properly grounded and protected by ground fault circuit interrupters (GFCIs) where required. Install the electric water heater, dryer, and washing machine according to manufacturer's instructions. Coordinate with the general contractor, also known as GC, to relocate walls and install new lighting as needed. In summary, when dealing with electrical installations, especially in commercial spaces such as the physical therapy office described, it is paramount to adhere strictly to the National Electrical Code, known as NEC, and any applicable local codes. The NEC provides comprehensive guidelines to ensure electrical safety and proper functionality. While there may not be specific sections exclusively for physical therapy offices, several NEC articles will be relevant. Article 210 covers branch circuits, which is directly applicable to the installation of receptacles and lighting. The NEC specifies requirements for the number of receptacles required in certain spaces to prevent the overuse of extension cords and power strips, which can be fire hazards. For countertop spaces, like the reception area mentioned, the NEC typically requires receptacles to be installed every 12 inches to 24 inches, depending on the specific use and layout of the counter. However, the recommendation of one receptacle every 3 feet provided in the initial guidance aligns with general best practices for commercial spaces where various electrical devices, such as computers, printers, and other office equipment, will be used. For general wall spaces, the NEC mandates that receptacles be installed so that no point along the wall is more than 6 feet from a receptacle. This is often interpreted as a receptacle every 12 feet. However, in a physical therapy setting, it is prudent to provide more receptacles than the minimum code requirement to accommodate the various medical equipment and patient needs. Regarding wiring methods, the use of Romex, also known as NM cable, is permitted in many commercial installations as long as it is installed according to NEC guidelines. NM cable must be protected from physical damage, typically by installing it within walls or ceilings. In the space above the suspended ceiling, NM cable can be run along the joists, but it should be supported and secured properly. When running NM cable through metal framing such as steel studs, appropriate bushings or grommets must be used to protect the cable from abrasion. The existing EMT conduit that is already in place and jam-full presents a challenge. It is advisable not to overload existing conduits, as this can lead to overheating and potential fire hazards. Instead, consider installing new conduits or exploring alternative wiring methods to accommodate the additional circuits. When installing new EMT conduit, it is crucial to follow the NEC guidelines for conduit fill. The NEC specifies the maximum percentage of the conduit's cross-sectional area that can be occupied by conductors. This percentage varies depending on the number of conductors in the conduit. Exceeding the conduit fill limits can make it difficult to pull wires and can also lead to overheating. Dirting of conductors is another critical consideration. When multiple current-carrying conductors are installed in the same conduit or cable, the ampacity of each conductor must be reduced or derated to prevent overheating. The NEC provides tables that specify the derating factors based on the number of conductors and the ambient temperature. The initial guidance suggested installing pull points or junction boxes every 10 feet in a new EMT conduit run. This is a good practice because it makes it easier to pull wires through long conduit runs and minimizes the risk of damage to the conductors. Another option mentioned was using wire mold, a surface-mounted raceway system, to run new circuits. Wire mold can be a convenient solution for adding circuits without having to open up walls or ceilings. However, it is essential to ensure that the wire mold is appropriately sized for the number and size of conductors being installed and that it is securely mounted. When stapling NM cable to ceiling joists, whether running parallel or perpendicular to the joists, the staples should be installed in a manner that does not damage the cable. The NEC specifies the maximum spacing between staples to provide adequate support. For new drop-in light fixtures, using jack chain for support is indeed a best practice. Jack chain is specifically designed for supporting light fixtures and provides a secure and reliable means of attachment. Using the existing wire grid to support new fixtures is generally not recommended, as the grid may not be designed to support the additional weight. Regarding the electric water heater, dryer, and washing machine, these appliances will require dedicated circuits with appropriate ampacity and overcurrent protection. The NEC provides guidelines for sizing these circuits based on the appliance's power requirements. It is also crucial to ensure that these appliances are properly grounded to prevent electrical shock hazards. Ground fault circuit interrupters, also known as GFCIs, are required in certain locations to protect against electrical shock hazards. The NEC specifies where GFCIs are required, typically in wet or damp locations such as bathrooms, kitchens, and outdoor areas. In a physical therapy office, GFCIs may be required in areas where water is present or where patients may be in contact with water. When coordinating with the general contractor, GC, it is essential to communicate clearly about the electrical requirements of the project. This includes the location of receptacles, switches, and lighting fixtures, as well as the routing of electrical wiring. It is also essential to ensure that the electrical work is coordinated with other trades such as plumbing and HVAC to avoid conflicts and ensure a smooth installation. Ultimately, completing the electrical work should be done in accordance with all applicable codes and regulations and should be inspected by a qualified electrical inspector to ensure compliance. The electrical inspector will verify that the work has been done safely and correctly and that it meets the requirements of the NEC and local codes. Some additional topics to consider include emergency lighting and power. The NEC requires emergency lighting in commercial buildings to provide illumination in the event of a power outage. Emergency lighting must be powered by a backup power source, such as a generator or battery system. In a physical therapy office, emergency lighting may be required in exit pathways, stairwells, and other critical areas. Also consider the installation of a fire alarm system. A fire alarm system is designed to detect fires and alert occupants of the building. Fire alarm systems typically consist of smoke detectors, heat detectors, pull stations, and audible alarms. The NEC and local building codes specify the requirements for fire alarm systems in commercial buildings. Surge protection is another consideration. Electrical surges can damage sensitive electronic equipment, such as computers, medical devices, and phone systems. Surge protection devices, also known as surge suppressors, are designed to protect equipment from electrical surges. It is advisable to install surge protection at the main electrical panel and at individual outlets where sensitive equipment is plugged in. Furthermore, consider energy efficiency. There are many ways to improve the energy efficiency of an electrical system, such as using energy-efficient lighting, installing occupancy sensors to turn off lights when rooms are unoccupied, and using programmable thermostats to control heating and cooling systems. Improving energy efficiency can save money on electricity bills and reduce the environmental impact of the building. It is also beneficial to document all electrical work. Accurate documentation of the electrical system is essential for future maintenance and repairs. Documentation should include wiring diagrams, panel schedules, and equipment specifications. This information should be kept in a safe and accessible location. In summary, electrical work must be performed to the highest standards of safety and quality. By following the NEC guidelines, coordinating with other trades, and working with a qualified electrical inspector, you can ensure that the electrical system is safe, reliable, and energy efficient. Finally, it is vital to remember that local codes can vary, so it is crucial to consult with the local authority having jurisdiction, also known as AHJ, to ensure compliance with all applicable regulations. The AHJ may have specific requirements for electrical installations in physical therapy offices that are not covered by the NEC. Consulting with the AHJ early in the planning process can help to avoid costly mistakes and delays. Some jurisdictions may require a licensed electrical engineer to review and approve the electrical design for commercial spaces. An electrical engineer can provide expert guidance on complex electrical issues and ensure that the design meets all applicable codes and standards. Furthermore, consider future expansion needs. When designing the electrical system for a physical therapy office, it is essential to consider the potential for future expansion. Providing extra capacity in the electrical panel and conduit system can make it easier to add new circuits and equipment as the business grows. It is also important to consider the location of the electrical panel and other electrical equipment. The panel should be located in a readily accessible location and should be protected from physical damage. Also, think about the accessibility requirements. The Americans with Disabilities Act, also known as ADA, set standards for accessibility in commercial buildings. These standards may affect the location of receptacles, switches, and other electrical equipment. It is important to ensure that the electrical system complies with all applicable ADA requirements. Consider the use of smart technology. Smart technology can be used to enhance the functionality and energy efficiency of an electrical system. For example, smart lighting systems can be programmed to adjust the lighting levels based on occupancy and time of day. Smart thermostats can be used to control heating and cooling systems remotely. Consider regular maintenance. Regular maintenance of the electrical system is essential to ensure its continued safety and reliability. Maintenance should include inspecting wiring, tightening connections, and testing GFCIs. A qualified electrician should perform maintenance on the electrical system. And lastly, prioritize safety. Electrical safety should always be the top priority. When working with electricity, it is essential to follow all safety precautions and use appropriate personal protective equipment (PPE). Never work on live electrical circuits unless absolutely necessary, and always disconnect the power before working on electrical equipment. When in doubt, consult with a qualified electrician.